Friends, subscribe my channel Netbook of Physics and press bell icon for latest update.
Hello students, in this session we will discuss a problem based on relative motion between two stars, or you can say it's the logic will be same for the two satellites also. Now let us read the question. A star system consisting of two stars orbiting around a common center of mass. Consider one such system of stars of mass capital M and 3m, where m is given and distance between them is 2 into 10 to the power 10 meter. Calculate T of the system. So in this system, the two stars are orbiting around their common center of mass, that is the center of mass of that particular binary system. So the two masses are given and the distance between their masses, the center of mass m and center of mass 3m is given, and we need to find the time period of the system. So it looks like if say this is my mass m and this is my mass 3m, let's say this is mass 3m and their center of mass is somehow located over here, and we need to, this distance is given, that is d. Now we need to find the time period of such a system. So for this particular problem, we need to find center of mass first. So the particular position where the center of mass is located. So our first attempt will be calculation of center of mass. Calculation of center of mass. So as we know, for calculation of the center of mass, we can set our origin over any place. So let us say the origin be at this center of the small mass, that is smaller mass, that is mass of only m. So from this position we need to find the center of mass. So we can write the position of center of mass to be summation, we know that it is given as I equals to 1 to n m I r I divided by summation of I equals to 1 to n mi. So this is the mi into ri for each of the ith particle, where I will run from 1 to n for n particle system, and mi is there, and then denominator is the sum of the total masses. So in this case it will be m into 0, because the position of the m from this particular center only, it will be 0, that is m times 0 plus 3m time d divided by 3m plus m, that is 4m. So I can write over here RCM is equal to 3m into d divided by 4m. mm cancels, that is 3/4 of d, that is d is given as 2 into 10 to the power 10 meter, that is 3/4 times 2 into 10 to the power 10 meter, or I can write it as this 2 cancels, that is 1.5 into 10 to the power 10 meter. So the distance of the center of mass from the center of the smaller mass capital M is 1.5 into 10 to the power 10 meter. So this distance is 1.5 into 10 to the power 10 meter. So this distance will be 0.5 into 10 to the power 10 meter. So from this particular case I got R of M is 1.5 into 10 to the power 10 meter, and R of 3m will be 0.5 into 10 to the power 10 meter. Now we have to calculate the force that is acting in each of the masses. So how we can calculate the force? We know that is when they are rotating about the center of mass, there must be the force of gravitation that is acting between these two masses. So the next phase will be calculation of force acting on each of the masses, that is calculation of force. We know the force acting between them is the force of gravitation. So F gravitation is given as G times m into m, where m and m are the two masses, that is divided by d square. In our case it will be G into capital M into 3m divided by d square, that is the total distance between the center of the two masses. In our case that will be 2 into 10 to the power 10 whole square. So writing the value of this particular, we can write this F gravitation equal to G times 3 m square divided by 4 into 10 to the power 20. This is equal to 3 times G into, the mass is given as 3 into 10 to the power 30. Okay, that is whole square divided by 4 into 10 to the power 20. So this is in kg, this is in meter square, 3g. Now putting the value, we'll get it as 4.5 into 10 to the power 30 Newton. So this is the value of the force, or the force of gravitation, that is acting on each of the masses due to another mass. Now we know when a particle or when a mass rotate about a particular point in a circular trajectory, they need a centripetal force which acts toward the center. So in our cases, the force of gravitation will provide the required centripetal force to each of the mass. So we can say that is for uniform circular motion, we need F centripetal, that is F centripetal force is given by mv1 square divided by r1, and that is equal to 4.5 into 10 to the power 30. Now from this particular expression we know the value of r1, we have to calculate the value of v1. Let's say that our mass is m, so I can write it as v1 square equal to r1 divided by capital M into 4.5 into 10 to the power 30. So v1 square will be, r1 is given as 1.5, that is 3 by 2, that is 3 by 2 into 10 to the power 10 divided by, mass is given as 3 into 10 to the power 30, that is 3 into 10 to the power 30 into 4.5 into 10 to the power 30. So this 10 to the power 30, 10 to the power 30 gets cancelled out. We are left with v1 square equal to this 4.5 can be written as 9 by 2. So I can write it as this 3 cancels, that is 9 by 2 into 1 by 4, 1 by 2 into 10 to the power 10. So here we are getting 9 by 4 into 10 to the power 10. So v1 square equal to 9 by 4 into 10 to the power 10, or from here I can write v1 can be written as by square root, if we square root this, it will be 3 by 2, that is 1.5 into 10 to the power 5 meter per second. So this is the value of the velocity v1, linear velocity v1, in which the mass capital M is moving in a circular trajectory about this point. Now we know from the expression of the time period, we can write time period as the total circumference of the circle divided by the linear velocity. So I can write the time period as t equal to 2 pi r1 divided by v1. Now what is the value of r1? The value of r1 is 1.5 into 10 to the power 10. So I can write it as 2 pi into 3 by 2 into 10 to the power 10 divided by 3 by 2 into 10 to the power 5. So this 2 gets cancelled. Here it will left with 5. So our time period will be 2 pi into 10 to the power 5 second. Now for this particular system, we know the V1 and V2 will be different. as R1 and R2 are different, and we know for a binary system the value of omega must be constant. Now if we solve from this force, if we start solving by doing the centripetal force acting on the second mass, that is a mass of 3m, in that case also we will get the value of V2 will be different, but for time period we have to divide the R2 by V2. This particular time period will be same. For a system of the binary star, we know that is the time period is independent of for the which mass you are taking, because they are moving about the same point and you will have the same time period. So this is all about the expression for the time period of this particular system, in which the two masses are of mass 3 into 10 to the power 30 kg and 3 times of 3 into 10 to the power 30 kg separated by a distance of 2 into 10 to the power 10 meters. So first we have find the center of mass, then we have found the force of gravitation, and then we have equated that required force of gravitation with the required centripetal force. From there we have calculated the velocity. You could have also got omega also, and from there we have calculated the time period.